drives not full this time?
Oh, we called it.
I already addressed that, Jordan. Okay, so here's A. All right, B. Show that the slope of every line tangent to the curve, this is y equals 1 over 1 minus 2x to the third power. We want to prove that that's going to be positive. So, dy dx. Now, what I would do, since this is 1 over, you could apply the quotient rule, but in a case like this where it's just 1 over something, I think writing it as 1 minus 2x to the negative 3 power is just a lot easier. Then you just have to do the power rule chain rule. We agree? That makes it a little easier than quotient rule?
Yes.
Okay, so we're going to move the negative 3 to the front.
Wait, I'm forgetting the difference between the power.
Power
you just
rule.
chain rule versus the other one. You just the other one. Oh, never mind, because you have to chain rule to get the derivative. Yeah.
Whenever you have a power on the outside,
I
whenever you have a power,
take some time.
it's just power rule, chain rule. So that means you do the power rule, which we've been doing, which means move it to the front, take 1 away from the exponent. But then the chain rule means you have to multiply by the derivative of the inside. So we have 1 minus 2x. Be careful, I always see the mistake of adding 1 instead of subtracting 1 when we have the negative exponents. And then the derivative of the inside is going to be negative 2. So let's just rewrite this. That's going to make it a negative 6. Sorry, positive 6. Right? Negative times a negative makes it positive. So this is, right, this is the slope of the tangent line. We want to show, how do we know that this is positive everywhere? Well,
Because if no matter what number it is, when you put it in the fourth power, it's going to be positive.
right, this is positive, this is positive, therefore it has to equal a positive number. Good?
And why is it 5A and 5B just cause, or because no one's seen it?
I don't know.
Okay, I wanted to see if they were
You
related.
wanted me to make them
Well,
a
no, I
different
just
type
wasn't
of
sure if they
problem?
were- If there was like any relation.
Yeah, I'm not sure why I did that. Good
Because
question.
if there's relation, then I would have.
There's no relation between those two. So
Yeah.
maybe I should have made this example 5 and maybe this example 6. And then now we'll just have to cross this, and now we're out of, we got the wrong numbers. 7.
What should you do?
Okay.
Wait, what's Antone's screen pass? So I'll figure it out when we send it. Yeah.
Okay, so f of g prime. Okay, that's what we've been doing. We've been doing the chain rule. If we look at f of g prime, okay, remember, we think of this as the inside, f is the outside.
So is this just the chain rule?
So it's just the chain rule. So how would you rewrite this? It would be f prime of g of x, right, times g prime of x.
Oh, so it's just the chain.
That's just the chain rule.
Oh,
Now, right, I think I gave this example because I think you might have had something like this in the homework. There's 2 different ways that you could do this. You could apply the chain rule, or you could take whatever g of x is and plug it in, and then you could do the derivative of that. Is that what?
What's
did you-
confusing me at the moment is why is it f of u?
Because u is a function of
Oh.
x also.
Right. Got it.
U is g of x.
Yeah, yeah.
So you see here, I put f prime of g of x. You could, I could write that f prime of u times g prime of x.
What?
I prefer the
U is g of x. I'm going to show, there's 2 ways you could do it. So, here, one of the reasons I'm showing you both ways is that sometimes you don't know the actual function. Maybe you just know the values. Like on the quiz, remember how I gave you u and v? And like u prime was equal to 3 or something, and then v prime. So I just gave you values. So if I told you find f of g prime, you can't just, there's no way to figure out what the actual function is. So you have to go based on the formula. Understand? understand what I'm saying? Okay, because that could be a problem that you have on a quiz or a test, where you have the actual values. So there are two ways to do this. The easier way for probably most of you would be just figure out what f of g of x is first, and then do the derivative.
Oh, the whole thing?
Yeah. So,
Oh, yeah.
for example, if I just said, what's f of g of x? What is that equal to? No derivatives. Just f of g of x. What would you do? You would take this and plug it in here. So it would be 1 minus 1 over 1 over 1 minus x. So flip that around. And you would get 1 minus 1 minus x, which is equal to,
Negative x. So this is just a complicated way to write negative x.
so what's the derivative of that?
Negative 1.
Negative 1.
So that's the answer. I love that. That's amazing.
I like that way
Okay?
better.
That's what I just said. That's probably
the
the
other way
easier
doesn't
method.
Even, doesn't even like can't
The other-
possibly better than that.
The other method definitely takes a little bit more work, because what you're asking is what's f prime of u, and then what's g prime of x, and then plugging it into the formula.
Yeah.
It's not too bad. It looks okay.
That doesn't look fun because you have a quotient rule right there.
I know, but I'm telling you, you need to know both methods.
Do we really though?
I'm going to rewrite this as 1 minus u to the negative 1. So when I do the derivative, I get 0, and then bring the negative 1 to the front, so that becomes u to the negative 2, or 1 over u squared. And then g prime of x, well, take a look at g prime.
Miss Lisa,
Yeah?
how did we get the f prime of u to be u negative 2?
Because if you think of 1 over u as u to the negative 1,
Got that.
apply the power rule, so the 1 goes away.
Okay.
Okay. Now, you could do quotient rule for g of x, or you could, see now, this is where I was saying, before you only had quotient rule, but now that you know, or hopefully are understanding a little better about the chain rule, you could rewrite this as a negative 1 exponent, but we still have to do the derivative of the inside. So what would that look like? It would be negative, and then 1 minus x to the negative 2 times negative 1. Right, because the derivative of the inside would be negative
How's
1.
this one a
Why
chain
is
rule?
it negative 2 though? Isn't it, wouldn't it be the negative 1?
Negative 1, subtract 1 from the exponent.
I don't see a composite function in just G.
You shouldn't see any composite
Then why are
function.
we doing the chain rule? I don't get why we're doing this.
We're doing the chain rule because this is g of x is a composition of functions. Or you could have done quotient rule.
How is it a composition function?
It's 1 over 1 minus x. If it was just 1 over x, then it wouldn't be a composition of
Oh,
functions.
that's
But because it's 1 over 1 minus x, you have two terms here, then you have the composition. So this is 1 over 1 minus x squared. Okay. You're like, all that work and we could have just figured it out over here, but now we can apply that formula that we came up with,
Which one?
the f prime of u
Oh, yeah.
times g prime of x. So what's that? But, oh, you know what I put in here? X is what? Negative 1. And u, since u is g of x, what's g of negative 1? Not everybody.
Uh-huh.
1/2, okay. U is defined as g of x.
Oh, right.
But how
It's not easy. It's very it is a bit complicated because we're saying u is a function of g of x. So we're saying f prime of g of negative 1
So it's f
times
prime
g
of
prime
1/2
of
times
Wait,
1/2.
where do we get the negative 1?
It's f prime of 1/2 times g prime of negative 1.
Or just 1/2.
g prime of -1/2,
Wait, where do we get the negative one from?
right here.
Oh.
Okay, so f prime of 1/2. So here's f prime of 1/2 would be 1/1/2 squared. You're just going along with it right now, aren't you?
Yeah.
That's what I thought.
See how it looks right now.
I don't.
And then g prime of -1. So here's g prime is 1/1 minus x squared. So we're going to plug in -1. So it's going to be 1/2 squared. Right? 1 minus -1 would be 2.
I'm confused
Oh,
with
wait.
the difference of doing the g prime of x and plugging.
Did I make a mistake somewhere?
Because
It's a formula.
plugging g -1. Sounding weird.
Well, shouldn't it always be -1?
Yeah, it should be. Hold on. This is what I get for not looking at my.
I feel like I'll look at it later when I'm not like tired, and then I'll get it.
Oh, no. We messed up over here. This is a plus x.
That's
That's what I told you.
Well, I was just trusting you there, Miss Casey.
That's why, as soon as I got to that point, I was like, wait a minute, it's not -1. Okay.
Wait, how did we get plus that?
Okay, so let me explain.
Distributing a negative.
Are we okay with this? This is 1/1/4, so this is 4 times 1/4, we get 1. Over here, if you distribute the minus sign, this would have been 1 minus 1 minus -x, so that becomes a plus x. So it should have become a positive x, and then when you do the derivative of that, you get 1. So the fact that these came out the same, great, they should have. Well, let's take a look. Question?
What did we just do? Was my question.
The way we did it.
Would you like me to give you a different example, or should we look at the homework and see if there's something similar?
Explain what I think. Like,
There's
the way
Okay.
we did it this way, it doesn't look like chain. Like, it didn't look like the chain rule because I don't see the outside inside parts when we did it on the left.
The outside is f prime.
Of
F
of
prime.
U, but like,
U is g of x, so you kept u the same times the derivative of the
that's
inside.
What's that?
So when we, right
So
here,
U and
the
G
very
are the
first,
same.
the very first thing I talked about is that f is the outside, g is the inside. What you needed to remember is g and u are the same thing. It's just the way that they wrote it. It's just notation. But u and g are the exact same thing. Okay. Let's look at some of the problems from the homework, and then we'll see.
Oh, you did every other odd.
We did every other odd?
That's what it says.
Great. Adam?
So if we were doing it the first way, where we just like plug in everything, you wouldn't be able to plug in the x before you plug in the g and the f, right?
That's a very nice sound.
Because if you plug in the f, the x first, then it becomes -1 again.
Oh, you don't want to plug it in. You want to, no, okay, so you're right. In this case, you don't want to plug in the x, because you want to have x in your answer and then do the derivative. All right, guys, so I plugged in so I can use the marker so that the students that are not, or the student that's not here,
Miss Farber.
can see what I write on the board. I just have to change the setting.
She's probably not watching.
Okay. Well, if somebody else wants to watch the explanation of the homework, they can see it also. All right. Here we have the first set of problems. So it started with one.
So they gave us
Okay.
the U.
No, one is doable.
Okay, so number one, do you need me to clarify anything with number one?
So they're just giving us U equals to show us what the inside is.
Right, they're just telling us, sometimes students find it confusing when they tell you what U is, because I think it's, in this case, it's pretty obvious. We did a number of examples. we did 3x plus 1, that's the inside, outside sign. Did everybody get 3 cosine and then in parentheses 3x plus 1?
Yes.
Okay.
Whoa.
It was every other odd.
Wait, why 3?
So 5.
Oh, because the derivative of the
Outside, yeah.
of the
I'm
inside.
having trouble figuring out which problems to do, much less how to do this.
Wait, can you go? Wait, the derivative of keep the derivative of the
Outside is
times.
cosine. Keep the inside the same.
Oh,
And then times 3, and they just put the 3 in the front.
Can we do number 5?
Yes.
Can we go to the sukkah and just
No.
sleep?
It's so cold.
Yes.
Stop complaining.
I slept once.
Okay.
Guys, I'm afraid we can hear this all.
Number 5.
Congrats.
Okay, so number 5, I'm guessing we might want a little assistance with. I'm gonna probably need some more space. Let me. Yeah,
Then we can
actually.
see it, so
No, but now I want to do.
Oh my god, you're kidding.
what's wrong with it?
It's just like the derivative of the derivative of the derivative.
Ah.
Not like that, but
The derivative, the derivative.
Hold on.
Yeah, definitely not like that. 'Cause that's not worth it.
Why is this not working?
One plus cosine. Is that confusing me? Negative sign.
Yeah, like
Just
not
use
perfect
one
when you
one.
don't get it.
It's like the regular.
I know, that's why you do.
Jordan?
Okay.
Lie to us and make us.
Can I look at your book first?
Yeah. Of course. That's good.
All right, so number 5.
G. The red lines
Okay, y prime. Oh, ignore the red lines.
Where'd they come?
Because I was writing with
Yeah, I didn't realize.
this will be easier because then I can save it if you guys need to see it.
That would be helpful.
Okay, so y prime. So think about this is a chain rule with a quotient rule inside. Okay.
Can you put like how you did the before, like where you labeled like what to do for?
Well,
'Cause that's
oops, I didn't mean to do that. Okay. So in this case, there's really only one. Why do I keep doing that? There's really only number 1 and then 2 is quotient rule. Okay, so the first thing we're going to do is we're going to move the 2 to the front. Keep everything inside the same. And then it becomes to the first power. You don't need the 1, but just so you can see that. Times. Okay, now just look at what's inside. And we have to apply the quotient rule. So the quotient rule is low, t high. So the derivative of sine is cosine. Take high, d low. So the derivative of the bottom is going to be negative sine. Cross the line. And square the low.
You're blessed now.
Okay, so we don't want to leave it like this. We want to see how much of this can we simplify. So let's just take a look at the numerator over
doesn't that
here.
cosine it?
Okay.
One.
Yay. Okay, so
I feel like she's the only one who got that one. So.
hold on. I'm going to write it down.
What? Oh, thanks. 'Cause you got the epiphany there. I
So we have cosine x plus cosine squared x plus sine squared x. Don't multiply out the bottom, just leave that for now. So you notice, I think this is what Natalie was referring to.
Yes.
Cosine squared plus sine squared, that has to be equal to 1. Now we have what? Oops, it's supposed to be big.
Doesn't the bottom also equal oh no, this is
So what do we have here? We have cosine x plus 1.
Over 1 plus cosec squared, which is just cosine x plus 1. Right. That was the same one number. Oh, that is what I meant to say.
Can you, what's it
One over
called?
that.
Can you,
What could we do? We can cancel one of them and then combine the other one with the other denominator.
oh, no, I was thinking.
I just unplugged.
Oh, we can do
Isn't cosine x plus 1 is the same as 1 plus cosine x, right? So we're going to cancel this and then make this a 1. But then I can take these two, multiply them together. So I have 2 sine x over 1 plus cosine x squared. The 2 can go out in front. I mean, I would be fine with that. Putting the 2 in the numerator, that's fine. There you go.
What about u?
It's like a step and a step and a step.
Well, that's why I said I don't necessarily like to look at u. If you like to take it apart and do the derivative of u and then put it into chain rule, that's fine. I just chose to do everything all at once without.
Are we taking y of u?
No, they give us. Well, yeah, it is y of u because it's just that they're saying u is what's inside. Matthew?
What is NDER? The book said use NDER.
Oh, that just means you check on your calculator.
We don't have. So you haven't taught to do that yet?
You know how to find a
math
derivative.
8.
Math 8.
Oh, and it just looked like ender.
I know,
Enderiv.
it's,
It
I don't
says
know,
enderiv on my calculator. It's weird.
it's the notation that they use.
Oh.
So if it says NDER, that's the end derivative that's on your calculator, so. Okay, are we alright with this one now?
Yeah.
Alright.
Makes so much more sense in retrospect. I don't know why.
Hindsight's 2020.
Ty doesn't feel so confident.
Not at all.
How about 9? 9 was the next one.
Mine's good.
Oh no, that's fine.
9?
Yeah, it's good.
Wait, no. Well,
9
yeah,
is
I guess.
not good.
Oh no, you can skip it.
Way now.
You can skip it if you need to.
Oh, okay, so you're okay with this one?
Well, yeah.
This one you have to find the velocity as an object as a function of t.
Which is the
So
same.
you have to do the derivative. This one's really fast.
Perfect.
V is equal to derivative of the outside. So a derivative of cosine is negative sine. Keep the inside the same. Times the derivative of the inside. So pi over 2 is just a constant. So it's just going to be negative 3. We're okay from there? All right. Next one, 13. 13 is x plus, I'm going to write the square root of x as x to the 1/2 and then to the negative 2. So this is going to be the power rule, chain rule. So dy dx, we're going to move the negative 2 to the front, take away 1 from the exponent. So it's going to become a negative 3. And then we're going to multiply by the derivative of the inside. Okay, the derivative of x is 1. And then the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. Move the exponent in front, take away 1 from the exponent. Okay, so one thing I would like you to get in the habit of doing, if you can change negative exponents to positive, that's what I would like in terms of simplified
So
form.
that's the answer. Now we have to simplify it.
Now we're going to simplify it. Now, this whole thing here that's in parentheses is really a positive 1 power. So it's going to be a negative 2, and then in parentheses 1 plus, and then it's going to be 1 over 2 root x,
Oh, that's awful.
all over x plus x. You could do x to the 1/2 or square root.
Wait. 1 over 2.
Yep. Yep.
Because x to the negative 1/2 would be a square root of x in the
Oh, that's
denominator.
an x to
Why
the
does
negative
that-
1/2. I thought that looked like minus
Can you
1/2
write
for
it?
some reason.
If you leave a negative exponent, is that bad?
I didn't skip a step. Did I skip a step?
No.
Wait, how did you get 1 plus 1 over 2 right?
Oh, is that the part you're talking about, Natalie? This part here. So 1 over 2x to the 1/2 gives us the 1 over 2 root x. It's just, if you have negative exponents.
Oh,
Good. So
Say that again?
If you're if that, the one x plus x to the 1/2, the third, that, the one next to it, yeah.
Mm-hmm.
If we do all of that, we do a 1 over that, and then we multiply it by 1 over 2x to the 1/2, why isn't it 2x to the 1/2 on the bottom, in the denominator?
Because this is a positive 1 power.
Yeah, but you still have a fraction, right?
goes down here.
But if that's our total derivative, right? 1 over 2x to the 1/2. And if we're multiplying that times,
Mm-hmm. 1 plus that is being multiplied to this, to the -3.
yeah.
So we move this to down
But how
here.
come that doesn't take them to the bottom? too?
Because that's a positive 1 power.
But the whole thing is a fraction, right? So if you're multiplying two fractions,
What
don't
do you mean the whole thing is a fraction?
like, isn't it? It's not. You don't look at it as 1 over 2x to the 1/2 as a fraction, and then multiply it by a fraction of that.
Oh, I see.
Do you understand exactly?
I was lost, so I tuned out.
No, I'm trying to understand the question, and I'm not understanding.
If you like wrote it out like separately, like you have -2 times 1 over x plus x to the 1/2 to the 3rd power. Times 1 over 2x. 1 over 2x to the 1/2. So use those strips. Okay.
Okay.
Because that's all in the numerator, that's why.
Okay.
Okay. Let's look at, that was no. That was 13. 17. 17 question?
Yes, please.
It's so hard. Oh my
Okay,
God.
17, we have y equals, now I'm going to write sine to the 3rd as sine x to the 3rd.
That's what I did.
And then tangent, and I'm just going to put 4x in parentheses so I remember that that's also a composition. So here, this is really a product rule with chain rule inside for both parts.
Twice. Wow.
Okay? So there's a lot to consider here. Now remember, think of this as u and this is v. So our product rule is going to be u prime v plus v prime u.
And when you do u prime, you have to do chain rule. When you do v prime, you have to do
Right.
chain rule.
So if you're one of those people that likes to just separate it and then plug it all in, that's fine. But I think it's good to get in the habit of doing it all in the same step. So dy dx. Okay, so it's going to be u prime. So 3, keep the inside the same, take 1 away from the power, times derivative of the inside, cosine x. Times, so this whole thing was my u prime, right? Because that was the chain rule. Next, we're going to multiply it. So what's the other part? It's v. So that's tangent of 4x,
Then you take the.
right? That's v.
Oh, I get it.
Let me pause there. Questions?
Not yet.
Very well.
I feel like it's gonna be like a 7-page
No, the
paper
answer is
assignment.
so long.
All right, v prime. V prime. So derivative of tangent is secant squared. Keep the inside the same, that's 4x, times the derivative of the inside, which is 4, times, so this whole piece here was v prime. Because remember, I told you that each part has the chain rule within it. Now, u is going to be sine to the 3rd x.
Sine to the third x or sine to the x
Same thing. So there's my u. Of course, you know that you can have something switched around. It's okay. Now, there's
With
not
sine-
much that we can really do to simplify this.
Yeah, that's not
Sine to the 3rd x is, oh, right, yeah.
Yeah,
U
there we
is
go.
sine to the 3rd x. So.
Good.
So this is it, isn't it?
So what can we do? Well, not anything. I mean, here it's 3. I'm just going to put the powers back inside. So 3 sine squared x, cosine x, tangent 4x, plus, I'm going to move the 4 to the front as a coefficient, and then secant to squared 4x, sine cubed x.
That's the answer?
Yep.
Wow. Hate you. Fantastic.
Okay.
Do you need to put the times back in?
The
there,
only
or
way
you
that we could
combine them?
possibly combine some of the things like sine squared and cosine squared, there's not much you could do. Tangent, because this has a tangent of 4x and this is cosine x, it's not like it would have to have the same angle, like just x. But that's it. That's all you can do.
Well, I'm not excited for this next one.
Okay, 21. 21 is, now I'm going to rewrite it. It's sine squared. So I'm going to put sine of 3x minus 2, and that whole thing, no, sorry, that's a squared. So do you see how when I rewrite it, it's a little bit more clear what is the outside most part? Rather than put the 2 here, rewrite it so it's sine of 3x minus 2, and the whole thing is squared. Now, I have to apply the derivative 3 times. What's the outermost part?
Power.
Okay, the power rule. What's the next part we're going to take care of?
Sine.
Sine. And the third part? 3x minus 2. All right, let's try it. First part, we're going to do power rule. 2 moves to the front. Everything on the inside stays exactly the same. So it's going to be sine of 3x minus 2. And then it's going to be to the first. Okay, so we could just leave it. Times, this is the next part, right? Taking care of the sine, which is cosine. Keep 3x minus 2 the same.
Times 3.
And finally, this is step 3
Not awful, not awful.
times 3. It's not awful. When you, the thing about the chain rule is, again, the more practice you get, you'll find that it's just do this step first, then this step, then this step. It's the same thing over and over
It's
again.
just long and annoying.
Oh,
Also realizing
you'll get over it. Okay. What can we do to clean this up? Not a lot. We could put the 6 in front. So 6 sine of 3x minus 2 cosine 3x minus 2.
They cleaned that up though more.
Oh, they did do more?
They did 3 sine, 6x
Uh,
minus 4.
Don't,
Got it.
Don't listen to them.
Don't worry about it.
Don't
They
listen
were
to them.
applying double angle form. Don't
Thank
worry.
you.
I'm fine with this. You don't need to know double angle and half angle formulas for AP.
Again? Forever again?
Well, I won't say ever again.
You said ever, that's fine. What's double?
She said ever.
I
The
heard
formulas
it.
that you
I
learned
heard it
in
too.
trigonometry and algebra, like
Joe
the
witness.
double angle, like
The ones that
sine
you
of
don't
2
remember.
theta is equal. Hold on.
Those
Oh,
lessons that
okay.
you
So this answer is fine for me. This is fine.
Cosine theta equals cos theta.
Okay, that was 21?
Yeah.
Yeah.
25.
Flex it. How big is this muscle, Jordan?
Oh, this one's-
Flex it, feel it.
GR
Not
D
hard.
theta.
Let me feel this.
same thing as DRDX.
Okay, so,
Theta is just the independent.
oh, drd theta, if you want to rewrite this with y and x, it's fine, but drd theta, what's the derivative of the outside?
Second square.
Secant squared.
Garbage.
Keep the inside the same, times the derivative of the inside,
1.
negative 1.
Negative, like, that's what it said.
That's what he said.
So it's negative secant squared.
Oh, number 29, didn't we do this on our notes? Oh, no, we did secant.
So we look at theta as an x.
Yes.
Okay.
Just think of this as what's r prime. Right? Same thing.
Ah.
Okay. We have to find the second derivative. So what's the first derivative of tangent?
Square x.
Secant squared.
We did this in the notes where?
We did secant, and then I think we did the the second derivative.
I don't see it.
Is it okay if I write secant squared that way? Makes it a little easier. Okay, now what's the outside?
2
2.
and inside
Secant stays the same.
times over.
What's this derivative of secant? Anybody memorize that yet? I think I heard it. Secant x tan x. So this is 2 secant squared x tan x.
Well, we need to memorize the.
Yes. Well, I told you, you don't.
Yes.
That was
Will that be in our
memorized.
calculators
There's,
then?
when it comes to derivatives, there is a lot of memorization.
Right. A lot.
But if you know sine and cosine, you can come up with all the others. It just takes time. So if you want to save time, then just memorize them.
Wait, where do we do that one with secant? I don't even see it in the notes.
Just find the second derivative of secant.
got it counted.
Wait, go back up for a second. Go back up for 1 second, please.
But then how do we do that without chain rules?
What's that? 33 we definitely need help with. Ah, so this is kind of like the one that we were just doing in the last part of the notes. Are we okay, Jordan?
Yeah.
Is it?
Could.
You're,
I'm asking about like our mental state.
Because like prime is equal to derivative.
are you okay?
Same notation.
This is where it starts to get hard in calculus. But it gets easier once you know it. Okay, so we did two different examples. We did one, or two different methods, shall I say. We did one where we took g of x and plugged it in for u, and then did the derivative, and then plugged in 1. That's, in my opinion, the easier way.
Agreed.
So if you want to take this, plug it in here. So in other words, let's figure out what f of g of x is equal to. So it's x to the 1/2 raised to the 5th power plus 1. So it's x to the 5/2 plus 1. Now I want to take f of g of x prime. Did I go too fast? Okay, I'll pause.
How many parentheses?
Well, because I'm taking this whole thing prime. The other way to write it would be to write the little circle f of g prime of x. Okay, just this one's easy now. 5/2 x to the 3/2 plus 0. So now I want to evaluate.
We're supposed to plug in 1 for x.
Well, yeah, now we'll plug it in.
Oh, yeah.
And then we get?
5 halves, so 3 halves.
Yeah. I don't feel like writing it all over again. So it's 5/2.
The answer's 5/2.
Right, because 1 to any power is going to be, right, the square root of 1 is 1, cubed is 1.
Oh, yeah, you're right.
So it doesn't matter what you, all right, fine, I'll write it. F of g of 1 prime is 5/2. There. Good. All right, 37.
Do we definitely need help with 37?
What's that?
What?
Do we definitely need help with
You want to try it by yourself?
Yeah, let's try it.
Okay.
No.
Will you write the question on the board?
Sure. Is everybody done writing this one?
For this one, should we do it the other way?
You think this one the other way?
Because it's 10x squared plus x plus 1 that's the g of x. Or u of x.
Oh, yes.
Oh, no.
So,
The other way's harder.
so this one might just be easier to use the other method where I did the derivative of one and then the derivative of other. Well, you don't have to. If you want to write f of g of x, what would that be? That would be 2 times this whole thing. All over this whole thing squared plus 1. Okay, guys, you don't have to multiply it out
Oh, you can.
because you can use the chain rule.
What?
2 bring to the front, but you have to use it within the quotient rule.
Oh, God.
You
You
like
You made it sound so simple and like, but
Wait, listen.
you laid it on us.
You lose hope and then you crush our dreams.
Or you can do the derivative of this, and then apply
But
the
then you
chain
still have to
rule.
use the quotient rule in that one.
Correct. So there's no way of getting out of the
Should I
quotient
do
rule.
it? Okay, Lodi.
In 3 minutes. Let's go.
You can do it.
What are you doing?
Which way are you?
Let me just multiply this out.
I thought we weren't going to do that.
No, just the top part. The bottom part I'm going to leave.
Which are we doing? So now we're gonna do it.
Okay, so the derivative, it's remember, you're just gonna plug in 0, so it's gonna look like a complete mess, but then you plug in 0 and it all goes away.
But we have to get it to look like a complete.
Oh, come on, we could do it.
It's
So
the issue
low,
we're having here. So while you're finding the derivative.
D high, so that whole thing times the derivative of the top, that's gonna be 40x plus 2.
What are we doing derivatives for right now?
Take high, D low. Uh-oh, you're right, I did run out of room. The derivative of
Is
the...
this gonna be f of g prime to x right now?
Oh, thank you.
Okay,
Prime.
that's what got me really confused.
Okay, I'm kind of out of room here, so I'm gonna have to, so it's gonna be 2 times 10x squared plus x plus 1 to the first. Yeah, and then times the derivative inside, so that's gonna be times 20x plus 1, parentheses, all over,
Wait, oh. I don't get the second parentheses in the second part. After the minus sign, what's the second one after that?
it's such a mess.
Can we plug in 0
No,
now?
I'm not doing this.
You can plug in 0 now.
Wait, what's the second part?
Can we
You can't
take
read
it
that?
out of it?
No, I don't get what it's coming
Why,
from.
where's
That one, where's that come from?
This is the chain rule, so it's 2.
The
Keep
derivative
the
of
inside the same.
top, inside the same derivative of the bottom. Derivative of the inside.
Derivative of the inside would be 20x plus 1.
Oh, so you have to do the chain rule and see, I
Yes.
can never remember.
Yes.
I think Gabe kept was hard until.
Now, the nice thing is,
Great, I'm just gonna skip this.
the nice thing is if you plug in 0,
Sorry.
You get like negative one.
I'm not right.
you get 1 here,
Affected my head.
plus another 1, so you get 2.
You get negative 1.
Where are you from?
Huh?
Where are you from?
Huh?
Never mind.
So this whole thing here just gives us 2. You see that? And then plug in 0 here, so you get another 2.
This is ridiculous.
Plug in 0 here, you get 2.
This case of three. Quit.
No. Never quit.
You get 1.
Okay, here you get 1 times 2 times another 1, so just 2. Oh, look at that. And then all over.
So just look for the
So it's
normal
0.
numbers.
I hope it comes out to 0.
Wouldn't it actually just be?
That is the worst thing they could ever do to us.
It's-
Give us an
All right.
answer for.
Is it over?
Is there a way to do the calculator?
0 plus
Yay.
0.
Yeah, you can do this on your calculator. Okay,
That's
here's
so
the
awkward, I
thing.
circled the 0.
I will make, this is an optional worksheet if you want some extra practice with chain rule. Otherwise, just finish your homework, but I'll post this on Haiku with solutions. It's optional. I made one yesterday, or I made this up last year.
Jordan. Oh my god. Can I find you by the end of the day? Give your treasure.
Yeah.
I need to move.
I'll post the screencast. I've been deleting as we've been going on long.